Here we're continuing my video on working with these nth roots. It's starting to get long, and I thought it was best to split it in half. So this is one about solving equations and using these nth roots to solve equations, or solving equations that involve nth roots. So we'll start with this problem right here. And this one actually I'm going to do in two different ways. First way, I'm just going to look at undoing my root. If I look at it right here, is my nth root, and the big idea is I have a way to undo an nth root, so I'm going to solve that nth root first. I'm going to isolate it and then undo it. So let's come along and just get rid of everything that's in my way. I'll subtract the 3. Because remember, when we do this, we're doing order of operations backwards. So we have to first do the last thing we do, which is the addition and subtraction. 4 times the third root of x squared equals 92. I'm going to divide by 4. And the third root of x squared equals 23. Now here's really where we can break it up into two methods to try to solve this. So, first thing we can do, first method is working with it in radical form. So I'll come over here, cubed root of x squared equals 23. So to undo a third power, or a third root, I'm going to use a third power. So I get x squared equals 12,167. Now I'm going to undo my square with the square root. But remember, when we're undoing a square with a square root, we got to consider that we can get two answers. So I'm going to say the absolute value of x equals the square root of 12,167, which is approximately 110.3. So in this case, x can equal plus or minus 110.3, because again, we get two answers because we're a negative 110, positive 210 are going to square to the same number. So this is working with it as radical form. Now the other option I can always do is take this over to exponential form. So I can take the cube root of x squared and just write that as x to the 2/3 power. And then that's then a simple fact of, well, let's raise it to the reciprocal power. Because then again, using the properties of exponents, when I take a power to a power, I multiply the exponents, and 2/3 times 3/2 is 1. And when we raise 20/3 to the 3/2 power, we will get x, x is approximately, again, that 110.3. Now, this method of doing it is quicker, but we fall into the trap that it's not quite as obvious as it is over here. I'm taking the square root of a square. I got to do that absolute value. I got to do the plus or minus. I can have two possible answers. So if you just gave this answer right here, you would be partially right. But the truth of the matter is, we have two answers. We have to remember that negative one. So keep that in mind. Anytime we have a square involved with this, and we're undoing the square with the square root, we have two answers. And this works with any even power. Second power, fourth power, sixth power, eighth power. Whenever you undo an even power with its corresponding root, there are two possible answers. But the radical will only give you the positive answer. And the rational exponent also only gives you that positive value. So now let's try this problem. This one is already set up in exponential form. I'm going to look this time to make sure, but this is a third power on top, so I don't have to worry about that fact of, oh, when I undo the power with a root, with odd powers, you only get one root. There's odd roots, we don't have that problem. So we'll just come along and do this. Same thing, I got to get the x to the power all by itself. So I'll do my normal undo stuff, so I'll subtract the 23. And we get 5x to the 3/4 equals a negative 15. We'll divide by 5. We'll get x to the 3/4 equals a negative 3. Let's undo this by raising it to a power. So we'll raise it to the reciprocal power, 4/3. 4/3. And we'll get x equals, we're approximately 4.327. 327. Sorry, 27. But here's the rub. If we go ahead and check this, you go 5 times 4.327 to the 3/4 power plus 23, you're going to end up with 38 equals 8, which does not check. And your problem comes right here. And this might make a little bit more sense if we take this, what's happening, take this over into radical form. Because in radical form, we're saying the fourth root of x to the third equals a negative 3. And a fourth root is like a square root. Anything to the fourth power will be positive. So when we look at the fourth root, the range of this function is y is greater than or equal to 0. I cannot have a fourth root that equals a negative number. So this one is, this is what we call, well, not here. This is what we call extraneous. There is no solution. And it's not because we did anything wrong, it's because it's impossible to take a number. Anytime I take a fourth root, I'm getting a positive number. So it's possible for me to take 5 times a positive number, add 23 to it, and end up with only 8. So this problem is impossible. There is no solution. One of the reasons why it's so important to check your answers. Finally, let's look at this problem. This one has a whole lot going on. But again, I'm going to look at this right here. Here is my radical, so I need to get rid of everything else so that I can use my properties over here to undo that radical. That fourth root, sorry. So, again, I'll get rid of my 10. I'll get negative 3 times the fourth root of 5x. No, that's not a 5. 5x plus 1 equals a negative 18. And yeah, I have a negative number over here. But I'm taking my fourth root times a negative. So yeah, I will get a negative number. So I'm okay so far. I'll divide by that negative 3 to get down just to the root. And I'll get the fourth root of 5x plus 1 equals, what, 6? And now I will undo the fourth root with the fourth power. So I get 5x plus 1 equals 6 to the fourth, which is 1,296. And after undoing that radical, it gets me down to another problem. I'm not done yet, but I'm close there. So let's keep working on this. So here I'll work this one down. Let's get rid of the 1. 5x equals 1295. And finally I'll divide by 5, not an 8. Why keep doing that? And I'll come down to x equals, what, 259. Woohoo! And of course, important, take that answer, plug it back in, make sure it works. What do you have to worry about with a radical? Well, again, with even roots, we gotta, like the square root, gotta make sure we're careful about what's going in there. Let's maybe just take one more quick look, and it might be worth saying a little bit here. If I have the nth root of x, if n is odd, domain and range are real numbers. So if I have an odd root, I don't have to worry about what kind of answers I'm going to get out of it. I can plug in any numbers, I can get out any numbers. But when I have that nth root of the x and n is even, that means anything to an even power is going to be positive. So the domain for this, like the square root, the domain is going to be x is greater than or equal to 0. The range is going to be y is greater than or equal to 0. The answer you're going to get from an nth root will always be positive. I can't take the nth root of a negative number. And when it comes to solving, this whole idea when we're undoing, if I take the nth root of x to the n, or if I take x to the nth power and I raise it to the 1/nth power to undo this, I'm going to get the absolute value of x. I will get two answers. So I always need to look for that, be careful of that, and also look for extraneous answers. Those are going to come up with this because you might get a point that in order to make it work, I need to plug in an x value that is less than 0. Or, as I work down the problem, I need this root to be negative, to be less than 0, so it's not in the domain and range. So be careful on those.